Hello and welcome to this tutorial on a universal joint. So there's 7 different items, and you can see here there's a couple of quantities of 2. So there's 7, 8, 9 parts with a materials list. So this drawing set has these different parts. So I will assume that all of these parts are already made, and this is just an assembly video. So we'll go through some of the assembly and how to make it a fully functional universal joint. So we'll look at here. So here's those different components. So I'm going to go to new, and I'm going to create a new assembly file. Okay. So we have our assembly file now, and it's already jumped right in. But in order to get to this insert component, we click on that insert component. So I'm going to actually browse in that folder. So this is my folder. I have it in downloads, but if I look at a little bit the preview window, I can see I want to start with the 03 part first. So I'm going to open that up. Again, for your first parts in an assembly, you always want to just click that green tick box. That fully fixes it, and that fixes it so that the origin of the part and the origin of your assembly are one and the same. So that puts all of those planes right where you have for your first part. So that's our first part. And now we're going to insert another component. So we're going to start with this component here, and we'll start installing. So for any assemblies, I recommend putting in one part and mating it until it's fully defined, or until it's as defined as you want it, and then proceeding to the next. So our first part, that F means fixed, so it's fully defined. And now we're going to mate. And again, I want to mate surfaces, not edges. So I'm going to select those 2 surfaces, and we're going to mate with a concentric mate. It knows it wants that as a concentric mate. So now I want to make this as realistic as possible. So I'm going to select that surface of a shoulder, and I'm going to select that bottom. So in real life, that's how those 2 parts would interact. Okay, so now I can rotate it, but I can't move it anywhere else. So that part to me is fully defined right now because I want this part to be able to rotate. So although it has the minus sign, it is fully defined for what I want right now. I'm going to insert another component, and let's find out. We're going to use this handle now, and we'll click that into place. And again, if I hold down the control, I can select those 2 faces before I go into that mate. So I want a concentric mate there, which is good. I'm going to mate that flat surface and that flat surface. That is correct. If it was opposite of what I wanted, I can flip it right there, but that looks good. So let's cancel that because I actually hit it too many times. So I'm going to select that face and that face, and my alignment is good. So I'm going to click OK. So now that gives me alignment on that shaft with that flat. And now I'm going to select the height. So I'm going to go from that surface to this surface. That's how it would actually be in the real world. I do not want to select these top 2 faces because really you're going to push that handle all the way down onto that shoulder. So that looks good. So now if we rotate, the handle doesn't come off at all, and I can rotate that all the way around. Now I'm going to insert my next part, and that next part is going to be 01 here, which is that knob. So I'm going to place that in there. Feel free to zoom in and out as much as possible. I'm going to select the mate. I'm going to select that face and that face to make those concentric, and that's good. So they're concentric, but they still doesn't have quite the right, it's not fully defined. So I'm going to select that face and this face. Again, shoulders that are meeting, not this surface and this surface. That is not a good mate in this situation. So with those 2 mates, Now I have my handle can go around with that knob on. So again, I can hold my knob and have it go around. Next, I'm going to select that spider in the middle, which is this one. So we're going to use a bit of an advanced mate here, but the first thing I'm going to do is I'm going to mate that and mate that concentric with that hole. So I don't need to actually insert my pins right away. Having just those holes aligned with the concentric mate is perfectly fine. Now what I'm going to use is I'm going to use this width mate. This is a pretty handy mate. It's kind of like symmetric, but just a little bit more robust. So I have the width of my selection, so that's these two planes. So that part's going to be between those, and then my tab is considered my actual part. So if I select both of those planes, what this width command has done is it's centered that part perfectly within the other part. So I've selected those 4 planes and now it's perfectly centered. So the gap on the left and the gap on the right are exactly the same. So now it can't actually move side to side in this view. So it can still rotate, which is fine. And if we look here, it's rotating fine as well. All right, so if I want to insert another one of these parts, but I don't want to go to insert, it's already here. If I hold the control key down, click and hold on that part and drag off and then let go, I can copy and create another part exactly the same. So I'm going to do the same thing with, I'm going to select this face, I'm going to mate it to this other hole. So that's looking good. And again, we'll do that same with mate to get it fully positioned. So those 2 faces as the width, and then these 2 faces, again, rotating and zooming in and out to get you where you need for those mates. So that's good. So I'll have a quick look and see everything's functioning quite nicely. So now what I'm going to do is I'm just going to mate this surface and this surface. So we'll go over to the standard, and it can't be a coincidence. You can make it parallel, and hopefully those holes line up. The other way you could create that mate is, so let's go down here. And we'll exit out of that. So I still don't have that mate. So if my holes are perfectly aligned, I can select those 2 faces and do a concentric mate on that. So if my housing is completely correct, and part of this exercise is to actually try and figure out the sizing and the location of that hole for it to be correct. But mine is fully correct. So my hole, by aligning that hole, I can still have that universal working correctly. Again, if I don't have it perfectly aligned, what you can do is you can make both of these surfaces, mate them to be parallel, and that way you can see whether your hole lines up. With them being parallel, then you can come in here and make any adjustments you need to this actual housing. So in order to do that efficiently, I'm going to edit my part. So first I need to save my assembly. I have not saved that yet. We'll call it assembly 2 and we'll put it in there. That's fine. So by editing the part, I'm actually opening the part, but it's within my assembly. So all of my components are there with me. And now I can edit my actual initial sketch to get everything perfectly aligned. But again, because I know my dimensions already, I'm able to get that perfectly aligned right off the bat. But that edit part is a powerful function in order to be able to change your assembly as you go. So you can see it rotating here nicely. So the last thing I need to do is insert my pins. I have, this one looks like the long one maybe. Yep, and so this one is the long one, so I'm gonna mate that. And I'm gonna use the spider for my concentric mate, which is there. And then I'm just gonna select that face and that face. And that's not going to be a coincident mate because it's a circular face. You're just going to use that tangent. And when we look at the other side, it's mostly through, which is fine. Then I am going to add that last pin. And for this one, there's actually 2 required because it doesn't go all the way through. So first I'm gonna mate those 2 parts, get those concentrically aligned, and we'll just, with the outside, or what you can do, we'll cancel that. So this is concentrically aligned. We want to push these pins all the way in until they're basically tangent with that. So if I select this face and that round pin, the shaft, you can get a tangent mate on that, and that would be, you're basically pressing this pin in until it bottoms out on that end. So we want to create a second one of those pins, again holding the control key down, clicking and holding on that part, and you drop and drag a new part on there. So I'm going to mate that face and that face, gets them nicely aligned, but you see it goes too far in your part and you might lose it. So actually I'm going to mate this, and we'll zoom in and get to that center. We'll make those tangent first because now I can actually still see my pin. Sometimes it gets buried in your assembly and is a little bit harder to find. So then I do that concentric mate. So now we have our fully assembled part and things are going around and everything looks correct. So I actually want to create an assembly drawing with this. So, and if that's the case, I want to actually have a static version of this. So I'm going to create one more mate. I'm going to select my front plane of my assembly, make it a little bigger here. And then I'm going to choose on this handle. So I think that was the second part we added. We'll go to the handle here. So that handle, we'll take this plane and that front plane, and we'll just create a mate so that it is always in the same location. I don't like that angle, so I'm gonna put it at, let's say 135, just so it's offset a little bit from straight on. So this is a fully rigid now assembly. So this is what I would use if I were going to make a drawing, whereas the version without that mate is what I would use for just showing the movement of the assembly. So I'm actually going to create 2 different configurations. So the first one being a default, and the second one being called, we'll call move, because this is the one that will be moving. So I will suppress that angle mate for the move and leave that angled mate for the default, which we'll actually rename. So if I click once and then a slow click twice, and we'll call this one stationary. So now I have 2. So right now it's stationary, and that's because that last mate is unsuppressed. And if we go move, we can move, everything's rotating. And when we go look, that angled mate is suppressed. So that's the universal joint with that housing and getting everything moving correctly. Thanks for listening and have a good day.